Here's another maximization or minimization and optimization type of a problem. The intensity of a light source at a distance is directly proportional to the strength of the source and inversely proportional to the square of the distance from the source. Okay, that makes sense. So intensity is directly proportional to the strength of the source and inversely proportional to the square of the distance. So if I make this like 1 over d squared, that's what my intensity is going to look like. And directly proportional to the strength of the source. So this would be the strength. So I guess I could write this as S. That'd be good. So the intensity is the strength divided by the square of the distance. Now I have two light sources, one twice as strong as the other, and they're 12 meters apart. At what point on the line segment joining the sources is the intensity the weakest? Okay, so I'm going to draw myself a picture here real quick. I have one source going this direction. I'm going to have another light source in this direction. I know that this distance here is 12. And I know that one source is twice the other. So I'm going to call this intensity 1 and this intensity 2. So intensity 1, I'm going to make 1 over d squared. And intensity 2, I'm going to make that the one that's twice as strong. That's 2 over, but not d squared. If I'm at a distance here of, say, 6, then I1 is 6 away, but actually 6 should be in the middle, huh? If I'm here at 6, then 6 was a bad choice. Sorry about that. Let's pick something else like 4. So if I'm here at 4, I1 is a distance of 4 away, but I2 is a distance of 12 minus 4 away, or 8 away. So I really need this to be 12 minus d squared. So this would describe how far apart these guys are. And I know that I have a restriction that d must be on 0 to 12. So the total intensity, say IT, the total intensity would be I1 plus I2. But that is going to be, the total intensity is going to be a function of d. So intensity as a function of d will be 1 over d squared plus 2 over 12 minus d squared. So now I have my function that's going to give me my intensity. And notice it's kind of nice. It's only a variable of d. So I need to try to figure out when the minimum is. I need to find a minimum. So that means I'm going to do what I always do. I'm going to take a derivative. So di dd, okay, that's kind of weird notation there because of the double d's, because my variable is d, but that's just the same as saying, well, I prime of d. That first derivative is going to be a negative 2 over d cubed, and this could be plus 4 over 12 minus d cubed. Now that may seem kind of magical to you. If I take this derivative, it's a negative 4, but it's a chain rule, so I take the derivative of this piece, I get a negative 1, so that double negative is what gives me my positive right here. If you didn't see that, just go off to the side and spend a second taking the derivative. Now to solve this, I need to set this equal to 0. Because the idea here is I'm going to look for critical values. So in order to set this to 0, well, let's just go ahead and make it equal to 0 and solve it. I'll get negative 2 over d cubed plus 4 over 12 minus d cubed equals 0. So that would then imply if I multiply through by the LCD, which is just a product of these guys, it'd clear the fractions. That'll give me negative 2 times 12 minus d cubed plus 4d cubed is equal to 0, which then implies that, let's see, 4d cubed is equal to 2 times 12 minus, oops, this is supposed to be cubed. There we go. 12 minus d cubed. And I'm trying to isolate d here. So this implies that if I move the d cubed over here, I'll have 4 over 2, which is 2, is equal to, and this is going to be 12 minus d over d, and all of this is cubed. So remember, this right here is just equal to 2. So if I take the cube root of both sides, I get the cube root of 2 is equal to 12 minus d over d. And I have a couple more steps to go. So I need to multiply by d on both sides. I'll get, see, the cube root of 2d plus d equals 12. I move this d over and multiplied by d to cancel here. And obviously the d over here. Now if I factor out this d, I will get d equals 12 divided by the cube root of 2 plus 1. So this value of d will make this function 0. So this gives me a critical value. This is a critical value. Now in order to evaluate this, I really kind of need to get an approximation here. So if I stick this in my calculator, I'm going to see that's approximately, going out 4 places, 5.3099. So now I'm going to do what I always do. I'm going to take a look at I prime of d, and I'm going to work with my critical value, 5.3099. Pick a value smaller, how about 1? And when I evaluate the first derivative, I get a negative value. I don't really care what the actual number is. It's just whether it's positive or negative. And I'm going to pick something bigger, and how about 10? And when I do that, I get a positive value. So this tells me that my derivative is negative. It's going down. At 5.399, I get a 0, so it's horizontal, and then it's going back up. So that means I've got to have this situation, which means a minimum at 5.3099, which is actually, I should say approximately, because it's actually 12 over the cube root of, cube root of 2 plus 1. That is actually the value of d, where I get my minimum. Now remember, I wrote I1 as being 1 over d squared, and I2 was 2 over 12 minus d squared. So to figure out where the minimum value is, I need to go back to this drawing. And because this was I1 and this was I2, I need to go a distance from here, out here, a total distance of 12 divided by 3 root 2 over 1. And then the distance in this direction will be 12 minus 12 divided by 12 minus, oops, that shouldn't be like that. My bad. That is simply 12 minus 12 over the cube root of 2 plus 1. So obviously if I messed that up too. Hope that didn't bother you too much. That's supposed to be a plus 1. I kind of missed the plus sign. So if I add these together, obviously what I'm going to end up with is 12 total distance from here to here. So this will actually give me my location, and at that location I'm going to have the weakest intensity from both of these lights.